All right, let's talk about nomenclature. So nomenclature is really important because as a scientist, I don't go around saying H2O plus K. No, I say water reacts with sodium to produce, all right? So I have to be able to translate names into formulas and formulas into names. When we have our chemical formulas, there's a number of things to keep in mind. We have our elemental symbols, and then subscripted are the number of atoms. So this is really important. You have to understand that our chemical formulas, we have to have those numbers subscripted. So here, this would be correct. Okay, this is incorrect. Okay. So make sure that we are subscripting when we put the number of each atom. Okay, so when we look at these, we have the symbol for the element, we have the number of that element with the subscript, and then if there's no subscript, it's implied that there's just one of them. As we'll see too, there are things that are what we call polyatomic ions. So this NO3, okay, this is a polyatomic ion, okay? And so that polyatomic ion, everything stays together. So in this situation, we have magnesium, and then we've got this NO3 group. This is magnesium nitrate. So I have one magnesium, and then that nitrate is written in parentheses, indicating that I have two total nitrate groups. So if I were to look at that, I'd have one magnesium, two nitrogens, and 6 oxygens total in that whole formula. Now, if we only have one of a polyatomic ion, we don't use the parentheses. So let's say I had something like potassium nitrate. I would write that as KNO3. Okay, I only have one potassium and I have one total nitrate group. So we only use those parentheses if we have multiple of a polyatomic ion group. Okay, when we look at each of these things, we're going to have two different rules for nomenclature. We're going to have rules for covalent compounds and rules for ionic compounds. So our covalent compounds, they share electrons, covalent, okay, together. So we have covalent bonds. So our covalent compounds are typically a nonmetal with a nonmetal, all right? So you got two nonmetals or more than two nonmetals bonded together. For our ionic bonds, it's going to be with a metal and a nonmetal, or we'll have some sort of polyatomic ion situation. So our ionic bond, okay, can also be a metal with a polyatomic ion, or there's few rare cases of this, but a few of these compounds exist, or a polyatomic cation with nonmetal, or another polyatomic ion. Most polyatomic ions are negatively charged, they're anions, but there's a couple of polyatomic cations out there. So occasionally you'll see a polyatomic cation that obeys the ionic bonding rules and nomenclature. Okay, but most of the time it's going to be some sort of a metal cation along with a non-metal anion or a polyatomic anion. Okay, and so what we'll see is with our ionic nomenclature, we're going to have a metal plus our nonmetal, or a metal plus our polyatomic ion, and so it'll be some sort of cation and then an IDE ending. So if I have something like potassium and oxygen, I would have potassium oxide. So there's that IDE ending. Okay. Now, what we'll see with ionic bonding is that we do a charge balance to figure out how many of each species are in the formula because we have charges there. Now with covalent bonding, because we're sharing electrons, we don't have any sort of charge balancing. So what we get there is we have to use prefixes in order to figure out how many of each element are present within the formula. So we're going to look first at our covalent compounds, and then we'll slide into ionic because there's a lot more things to deal with ionic bonds than there are with covalent bonds. So covalent bonds we'll do first. Those will be much quicker, and then we'll start going through all of the different rules and situations with our ionic compounds.